Look at these heavy storm clouds gathering over the lush peaks of the Sahyadri Mountains. When the torrential monsoon season hits, the Khandala Ghat transforms from a scenic route into a hostile, looming threat. This multi-lane highway curving through the terrain is the main artery here, and you can see the massive congestion. For years, the steep gradients forced heavy freight trucks to crawl at a snail's pace, creating agonizing bottlenecks that stranded drivers for hours. But the traffic was only part of the problem. That heavy rain relentlessly destabilizes the high slopes above the road, creating a constant, terrifying threat of sudden landslides and falling boulders that actively endangered the lives of the commuters below. This specific stretch of road is the primary transit artery connecting Mumbai, India's financial capital, to Pune, a massive IT and educational hub. When rock falls or accidents shut this route down, it severed an economic lifeline, bleeding millions of dollars in delayed freight and lost productivity. The authorities realized they were trapped. The surrounding mountain terrain was far too violently unstable to negotiate with or simply widen. If they wanted to save the route, they had to bypass the treacherous surface geography entirely. The blueprint for the missing link was incredibly bold. For $1 billion, engineers proposed drawing a brand new 13.3-kilometer straight line directly through the mountain range. Executing this meant ripping the earth apart. The plans called for violently excavating over 8.5 million tons of solid, dense volcanic basalt rock. But this introduced a massive engineering paradox. The entire point of the project was to escape the unstable landslide-prone surface. Yet aggressively hollowing out a mountain inherently risks triggering massive subterranean cave-ins. To permanently neutralize the mountain's brat, the construction teams had to attempt an excavation so massive and delicate that it bordered on the impossible. The massive centerpiece of this subterranean master plan is a twin tunnel system stretching for nearly 9 kilometers deep underground. Each side houses 5 lanes of traffic, requiring a structural width of 22.33 meters. That exact dimension officially secured a Guinness World Record for the widest underground tunnel on the planet. How exactly do you carve a void that wide inside volcanic rock without the entire ceiling immediately collapsing and crushing the workers below? This cross-section of the tunnel face shows exactly how they pulled it off using the new Austrian tunneling method, or NATM. Instead of boring a single hole, NATM breaks the rock into smaller zones, excavated in phases. Instantly, the removed section is coated in quick-drying shotcrete. Workers applied 110,000 cubic meters of concrete and heavy steel supports, locking the shape. This method effectively tricks the mountain. By instantly distributing the immense overhead weight onto the new concrete arches, the surrounding rock remains perfectly stable before the fragile terrain above even realizes its core is hollowed out. Conquering the deep rock was only half the battle. The moment drivers exit its dark, enclosed safety of the tunnel, they are launched straight out over a dizzying, elevated drop into a deep valley. Look at this aerial view of a similar structure spanning a massive green valley. To bridge the massive gap between the mountain peaks here, engineers constructed a 650-meter cable-stayed viaduct. Anchoring a structure of this scale required extreme structural support. They built towering pylons that rise a staggering 182 meters directly into the air. From those towering pylons, 240 massive stay cables stretch down to grip the concrete. These cables are absolutely necessary to safely suspend the immense weight of a multi-lane heavy freight highway against the powerful high-altitude winds whipping through the valley. Bypassing the Khandala Ghat required the crews to master 2 completely opposite extreme environments, hollowing out the deepest basalt core of the mountain and then safely suspending heavy infrastructure high in the sky above it. When you build infrastructure in an unpredictable geographic zone, concrete and steel are not enough. You need an invisible layer of digital armor. The entire corridor is managed by a highly advanced SCADA system. It utilizes an AI-powered monitoring network that tracks tunnel air quality and traffic flow 24/7, analyzing the data instantly to make split-second safety decisions. This schematic of the twin tunnels highlights the ultimate fail-safe, connecting cross-passages blasted at precise 300-meter intervals. In an emergency like a vehicle fire, these passages allow trapped civilians to safely evacuate into the parallel twin tunnel. Pulling this off demanded a supreme human effort. Construction crews logged over 9 million man-hours of grueling, highly dangerous labor to bring this blueprint to reality. By carving a record-breaking hole through solid basalt and deploying cutting-edge digital failsafes, India permanently neutralized a deadly geographic obstacle. In doing so, they secured the economic lifeline between their greatest cities forever.
Like, share, and comment. Subscribe.